So this section is called an atomic level view of elements and compounds. So if we look at pure substances, they can be elements or they can be compounds. So in an element, we only have atoms of one kind of element present. Atomic elements are the most common. They're just composed of atoms. But there are some elements that are present as molecules. They are mostly present as diatomic molecules, meaning there's two oxygen atoms. They hang out together. We'll talk more about that later. But this would be a molecular element. If we're looking at compounds, compounds are going to have two or more different elements. And we categorize those based on what the individual particles are. Here we have molecules, so this is a molecular compound. Here we have ions, so ionic compound. The molecular elements are the diatomic elements. There are 7 of them, and you need to know them. It's these guys. Anytime we see one of those elements as an element, meaning it doesn't have any friends with it, it's not part of a compound, its formula is going to be 2, H2, O2, I2, etc. P4 and S8 are other molecular elements. They have more than 2 elements, but we're not going to pay attention to those. So how can you remember those 7 diatomic elements? So those are the yellow ones here. You need to know the yellow ones. So here, if we start at element number 7 and we make a 7, those guys plus naughty baby brother hydrogen are the diatomic elements. Another common one is, let's see if I can have enough space. A mnemonic: horses need oats for clear brown eyes.
No, we're not.
Horses need oats for clear brown eyes. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Any questions? Molecular compounds are usually going to have 2 or more nonmetals that are covalently bonded. So these contain molecules with the elements, atoms of those elements. So we've looked at water before. Dry ice contains CO2 molecules. Propane, like the propane in your gas grill, is C3H8, and here's a space filling model of propane. So we have individual molecules. Ionic compounds are composed of cations and anions. The cation is usually a metal. The anion is usually 1 or more nonmetals, and those are bonded by ionic bond, the attraction between the positive and negative charges. The basic unit of an ionic compound is the formula unit. There is no discrete molecule. So here we have an illustration of a sodium chloride crystal. Chloride, sodium, chloride, sodium, chloride, sodium, chloride. It's just going to repeat in that pattern throughout the whole crystal, no matter how big it is. And so if you wanted to call that a molecule, every piece of salt would have a different formula because it would have a different number of ions. The important thing is the ratio is the same. 1 sodium to 1 chloride. And so instead of messing around with things that don't matter and we can't even understand what they are anyway, we're just going to use the empirical formula. So this is called a formula unit. It is whatever things are in the formula. So it's not a molecule, but it's just what's in the formula. One of the formula, that's the formula unit. Any questions? And then we have polyatomic ions. So these should be somewhat familiar because they were on the list of things I told you to memorize. These are kind of a combination. So in nitrate, what we have is we have one nitrogen and three oxygens, and those are covalently bonded together. But as a unit, they have one extra electron. And so it's an ion because it's charged, but it has more than one element, so it's a polyatomic ion. And we will talk more about those soon. So very quickly, we are going to get into what's called nomenclature, which is naming compounds, and from their names, writing their formulas. And it is very important to be able to identify what kind of a compound you're looking at, because the different kinds of compounds have different rules for naming. So we're looking here for, is this an atomic element, a molecular compound, or an ionic compound? How about fluorine? Well, is it an element or a compound? It's an element. What kind? Horses need oats for fluorine, clear brown eyes. This is a molecular element. Mm-hmm. Why am I writing compound? My brain is melting. So, fluorine as a free element exists as F2 molecules. Whereas something like neon is an atomic element. It's just individual atoms. So its formula as an element would be Ne. But fluorine is one of the 7 diatomic elements. So that one was a little tricky. Okay, N2O. Element or compound? Compound. The clue there is you have 2 different elements, right? You have 2 different capital letters. So this is a compound. How do we identify if it's molecular or ionic? Does it have a metal in it? Ionic compounds have metals in them. Okay? Nitrogen and oxygen are nonmetal. How do we know? We look at the periodic table, and they are both to the right of that stair-step line, which tells us they are nonmetals. So this is a molecular compound. How about silver? That's an atomic element. Silver is one of the elements on the periodic table. It's not specifying any other elements in there. And it's not one of the 7 diatomic. Most elements are atomic elements. K2O. This is an ionic compound. Because potassium is a metal, which is probably not what first comes to your mind when you think of potassium. But its symbol is K, and it's way over there on the left side, right? And so, if you're trying to stay well hydrated in the heat, and you want to make sure you have enough potassium, right? You're not eating metallic potassium. You're taking in ionic compounds containing potassium ions because that's what your body uses. Fe2O3, ionic compound. Fe is iron, which does bring to mind metals, right? So we have a metal and a nonmetal. That's an ionic compound. Any questions?